Okay, here we are going to be looking at ballistic pendulum. Ballistic pendulum is a device used to measure the velocity of a projectile like bullets. A large wooden block suspended by two cords serves as the pendulum bulb. So when a bullet is fired into the bulb, its momentum is transferred into the bulb. The bullet momentum can be determined from the amplitude of the pendulum swing. Okay, so the velocity of the bullet in turn can be derived from its calculated momentum, and this is exactly it here. Look at the block here. So the bullet, this is the bullet fired into the block, and then when that happens, it gains a new position. It transfers its momentum to the block. Okay, so that is exactly what we have. So look at the diagram very well. You can see the L is the length of the rope, holding the block. But when it is displaced here, it will be at a little height h above its original position. And so if here is h, it means that here will now be L minus h. The remaining part of the pendulum will be L minus h. Okay, so let's see. According to the law of conservation of linear momentum, and since the block was initially static, and also both bullet and block move with common velocity, we have m1u1, that's for the bullet, is equal to m1 plus m2v, that's for the block. Because the bullet is fired into the block, so it is inside the block, so they move with a common velocity. And m1, of course, is the mass of the bullet, u1 the velocity of the bullet, v is their common velocity, m2 is the mass of the block. Okay, now also, since energy is also conserved, that is, kinetic energy of the bullet is converted to potential energy of the bullet and the block. So we have that Ke equal to, because energy is always conserved, Ke equal to Pe. What is Ke? Half m1 plus m2v squared. That's the kinetic energy of both the block and the. But what is their Pe, which is m1 plus m2gh? Then by the time we resolve that, we are going to get that v is equal to square root of 2gh. Okay? By the time you cancel m1, let's do that quickly. We have half m1 plus m2 v squared is equal to m1 plus m2 into gh. m1 plus m2 cancels m1 plus m2. By the time you multiply both sides by 2, v squared will be 2gh. That means your v now will now be square root of 2gh. So that is how we came about that. Okay, so we now have also from the diagram, if you look at the diagram, you see that L minus h is all over L, which is adjacent of hypotenuse. L minus h is adjacent, L is hypotenuse to theta from the diagram here, to theta. Okay, so that means L minus h, if we cross multiply now, is going to give us L cos theta. Making h solid of formula, your h will be L into 1 minus cos theta. So please note that formula. So if we now substitute that value for h with velocity v, okay, what are we going to get? We're going to have 2gh becomes 2gl into 1 minus cos theta. So when you're asked to find the velocity of a pendulum, this is the formula we use. Square root of 2gl into 1 minus cos theta. So look at this question here. It says a block of wood with a mass of 2.5 kilograms is suspended from fixed pegs by a vertical string of length. The length of the string is 3 meters long in a setup known as ballistic pendulum. A bullet with a mass of 10 grams and moving horizontally with a velocity of 300 meters per second enters and remains in the block. Find the maximum angle to the vertical through which the block swings. So you see, the first thing we did here in this question is to find their common velocity, knowing that m1u1 is equal to m1 plus m2v. Okay, so after substituting values, we get the common velocity to be 1.2 meters per second. Now, but also this common velocity is equal to this square root of 2gl into 1 minus cos theta, and we're looking for theta. Okay, so when we substitute the value for G and L, we got to this point, square both sides to remove square root here, then we divide both sides by 60 here, 0.024 equal to 1 minus cos theta. Cos theta now will be 1 minus 0.024, which will give us 0.976. Theta will be cos inverse of 0.976. It's cos inverse of 0.976 will give us 12.58 degrees. So that is the formulas to use when you are dealing with ballistic pendulum, depending on the question you are being asked. Okay, so I will stop.